Hello students. In the previous lecture, we learnt about how to find the inverse of a matrix by elementary transformations. We saw that the method is elaborate and requires a series of transformations. Now there is another method for finding the inverse of a matrix, and that method is called adjoint method. This method can be used directly to find the inverse. But then for understanding this method, you have to concentrate for some time on the lecture and go through it thoroughly and patiently. Now, before finding out what is the meaning of an adjoint, let us see what is the meaning of minor and cofactor of a matrix. Now, remember that any element of a matrix is denoted as small aij, where I and j denote the rows and columns. It is the ith row and the jth column that we are talking of over here. Now, what is a minor then? Minor is denoted by mij, capital Mij, and the cofactor is denoted as capital Aij. So remember, element is small aij and the cofactor is capital Aij, whereas a minor is capital Mij. Now take an example. Suppose A is a matrix containing the rows 2, 4 and -1, 7. That is, it is a 2 by 2 matrix. Now here, the elements of A11, that is a 1/1th element is 2. Similarly, A12 is 4, A21 is -1 and A22 is 7, as you can see over here. Now to find the minor of all the elements which are there, what we do first is that we ignore the first row and first column. That means we do not consider the first row and first column. What do we get remaining? We get 7. Now the determinant of any number is a number itself. So mod of 7, the determinant of 7 is 7. Thus, the minor of the first row, first column, that is M11 is equal to 7. Now, next step, what we do is that we ignore the first row and second column. The remaining element is -1. So we write M12 is equal to -1. Next, we ignore the second row and first column. Thus, we get the remaining element as 4. So, M21 is 4. Next, we ignore the second row and the second column. What we get remaining, M22, is written as 2 over here. Thus, we find the minors of the matrix. Now, how to find the cofactor? Cofactor is found out by the formula Aij is equal to -1 raised to I plus j into Mij. I and j correspond to, correct, they correspond to the row number and column number. So -1 raised to I plus j, that is row number plus column number, into Mij, the corresponding minor. That gives us the cofactor, that is Aij. Let us check it out for A11. A11 is equal to -1 raised to 1 plus 1 into M11. That is -1 square into 7, because M11 is 7, as you can see over here. Now -1 raised to any even number gives us 1. So -1 square is 1. So 1 7s are 7. So A11 comes out as 7. What is A12 then? Using it in the formula, -1 raised to 1 plus 2 into M12. That is -1 cube into -1, because M12 is -1. Now -1 cube, -1 raised to any odd number gives us -1. Thus we get -1 into -1, which is 1. What is A21? -1 raised to 2 plus 1 into M21. That is -1 cube into 4, which is -1 into 4. That is -4. And A22, -1 raised to 2 plus 2 into M22, which is -1 raised to 4 into 2. Remember, -1 raised to any even number is 1. So 1 into 2 is equal to 2. Thus, after getting the cofactor, we form a matrix of cofactors like this. So cofactor matrix is Aij, 2 plus 2 over here. Okay, remember, the elements go to the corresponding positions. That is 1/1th position is occupied by A11, that is 7. 1/2th position is occupied by A12, that is 1. 1/3rd position is occupied by A13, that is 1. 1/4th position is occupied by A14, that is 1. 1/5th position is occupied by A15, that is 1. 1/6th position is occupied by A16, that is 1. 1/7th position is occupied by A17, that is 1. 1/8th position is occupied by A19, that is 1. 1/9th position is occupied by A20, that is 1. 1/10th position is occupied by A21, that is 1. 1/11th position is occupied by A22, that is 1. 1/12th position is occupied by A23, that is 1. 1/13th position is occupied by A24, that is 1. 1/14th position is occupied by A25, that is 1. 1/16th position is occupied by A26, that is 1. 1/17th position is occupied by A27, that is 1. 1/18th position is occupied by A28, that is 1. 1/19th position is occupied by A29, that is 1. 1/20th position 2 1th position. 2 1th position is occupied by A2 1, that is minus 4, and 2 2th position is 2. Thus you get the cofactor matrix. Now I have given you this matrix. Find out the minors and cofactors of the matrix. Check whether your answer for cofactor matrix comes out as this. So we got a cofactor matrix as so, which is Aij, a 2 by 2 matrix. Now from the cofactor matrix, we have to find out what is the adjoint. Now adjoint of the given matrix is the transpose of the cofactor matrix. Yes. Now what is the meaning of a transpose? Transpose is obtained by interchanging the rows and columns of the given matrix. So we interchange the rows and columns of the given cofactor matrix to find the transpose of the matrix, and that is the adjoint of A. Thus we get adjoint of A, which is written as adj A, is equal to the transpose of the cofactor matrix. We have interchanged the rows and columns in the cofactor matrix, as you can see, to find the adjoint. That is 7 1, which was a row, has become a column in the adjoint. Similarly, minus 4 and 2 also has become a column over here. Thus we find the adjoint of matrix A. Now, using the adjoint, how to find the inverse of the matrix? This was our main aim, to find the inverse of a given matrix by the adjoint method. Now, the formula for finding the inverse is A inverse is equal to 1 upon mod A into adj A. Now, A was the given matrix. It was given in the question in the previous slide. From there, we can find mod A, that is the determinant of A. Solving it, we get the answer as 18. So, mod A is 18. Adds A, we already found out just now, which is so. And using this in the formula, we get A inverse is equal to 1 upon 18 into the matrix 7 minus 4, 1, 2. Thus, we find the inverse of a matrix by the adjoint method. Now, students, we have seen the method for finding the inverse of a 2 by 2 matrix by the adjoint method. Now, as we go further, as we solve sums, I will explain to you how to find the adjoint of a 3 by 3 matrix. So we start with the exercise here. The first question, just to give you practice, they have given find the cofactors of the following matrices. So a 2 by 2 matrix is given here. A is equal to the given matrix. To find the minors, first of all we ignore the first row and first column. Whatever is remaining is written as M11. So here M11 is 4. Then we ignore the first row, second column and get M12, which is minus 3. And then we ignore the second row, first column to get M21, which is 2. And then we ignore the second row, second column to get minus 1 as the remaining element. So M22 is minus 1. After that, we find the corresponding cofactors by using the formula which we learned in the previous slide. That is A11 is equal to minus 1 raised to 1 plus 1 M11. Remember from where that 1 plus 1 came? From the row number and column number. So thus, applying the formula M11 is 4, we get the answer for A11 as 4. Similarly, A12 becomes 3, A21 is minus 2 and A22 becomes minus 1. Now here, remember one thing, observe one thing students. Whenever minus 1 is raised to an even number, the minor and the cofactor are same. As you can see, M11 and A11 both are 4. On the other hand, whenever minus 1 is raised to some odd number, you get minors and cofactors as opposites of each other. As you can see, M12 is minus 3, but A12 is 3. Similarly, M21 is 2, but A21 is minus 2. On the other hand, what about M22 and A22? Correct. Both are coming same, that is minus 1, because minus 1 is raised to even number over here. So, this will help you. Keeping this in mind will help you in finding the cofactors quickly in any sum. The second sum, as you can see, it is an assignment for practice for you. Next, let us find the cofactors of a 3 by 3 matrix. Now concentrate properly for some time over here. Suppose A is the given matrix. First we ignore the first row and second column. And then we find M11 by writing the remaining elements as a determinant. As you can see in the determinant, it's a determinant of order 2 and 3, 5 and 0, 1 are the rows. Then we solve the determinant and get the answer for M11 over here. So M11 becomes 3. Next step, we ignore the first row, second column for finding M12 and solving the remaining, writing the remaining elements which are not ignored as a determinant, and solving the determinant, we get the answer for M12 as 8. Then we ignore the first row and third column for getting M13 and thus get the answer for M13 by writing the remaining elements as a determinant. Then we go to the second row, first column, we ignore it and get M21. And then we ignore the second row, second column and get M22. And then the second row, third column is ignored to get M23. Then we move on to the third column and the third row and first column. The third row, first column is ignored to get M31. The third row, second column is ignored to get M32. The third row, third column is ignored to get M33. Thus, by now you must have got an idea of how to find the minors for a 3 by 3 matrix. After that, the formula for finding the cofactors is the same. That is A11 minus 1 raised to 1 plus 1 M11, which turns out to be 3. A12, A13, A21, A22, A23, similarly the remaining 3. Okay. Now, just think about what I told you in the previous slide. Yes, whenever minus 1 is raised to an even number, you see that minor and cofactor remain the same. And whenever minus 1 is raised to an odd number, the minor and cofactor are opposites of each other. If you want, you can pause the video, study it properly, get it thoroughly in your mind as to how to find the cofactor, because believe me, adjoint method is easier than the transformation method for finding the inverse. But then you have to be thorough with both the methods, because in the exam time, suppose they ask you the adjoint method and you find the inverse by transformation method, no marks are given, and vice versa also no marks are given. So you have to be well versed with both the methods actually. Do the sum as an assignment in your notebooks. Now the second type of question, find the matrix of cofactors for the following matrices. That is, one step further we go. We not only find the cofactors but form them into a matrix. The question here, A is equal to the given matrix. It's a 2 by 2 matrix. You start by finding the minors. How to find the minors? I don't have to tell you now. Yes, by ignoring the first row, first column, you find M11, which is minus 1 in this case. Similarly, you find the remaining minors which are there. Then you find the cofactors by applying the formula for A, Ij, that is A11. And then you find the matrix of cofactors. How to find the matrix of cofactors? Correct. By writing all the cofactors in the proper order. A11 is written in the 1/1th position, A12 in the 1/2th position, and so on and so forth. You get the cofactor matrix that is there. That is all that there is to this particular sum. This sum, you can try it out as an assignment. It's a 3 by 3 matrix, but still you can practice finding the minors and cofactors and finding the cofactor matrix of a 3 by 3 matrix. Remember students, although I have told you the shortcut for finding the minors and cofactors, do not use it in the exam. Just check it out to see if your sum is correct. Do not write directly the cofactor without writing the formula for cofactors. Next question, find the adjoint of the following matrices. So we go one more step further. In this sum, a 2 by 2 matrix is given. So as usual, we find the minors of the given matrix and the cofactors. We also find the cofactor matrix. And then what to do to find the adjoint? Do you remember? Yes, you have to find the transpose of the cofactor matrix by interchanging the rows and columns of the cofactor matrix. Thus you find Aij, that is transpose, which is A adj A, that is adjoint of A. That is the end of the particular sum. Now remember, last year such a sum had come in the exam, board exam, that is find the adjoint of the given matrix. Now this sum can be done as an assignment in your notebooks. Find the adjoint of this matrix. Keep practicing, even though it is tedious initially. Later on it will become like second nature to you. Now regarding this question. This question I had already dealt with the same matrix 1 or 2 slides earlier. Okay, so Directly, the minors and the cofactors have been found over here. What we can do is, we can directly find the cofactor matrix by writing all the elements of the cofactors in the proper order, and then find out the adjoint by finding the transpose of the cofactor matrix. This sum can be done as an assignment in a similar manner by you by finding the minors, cofactors and finding the adjoint. Consider this sum as an important sum. Okay, the question is, if A is the given matrix, a 2 by 2 matrix is given, verify that A into adj is equal to adj into A is equal to mod A into I. Looks quite a handful, isn't it? Well, let us find out first what is adj A. So A is the given matrix. We find A11 here. See, I have not found out M11 separately because that is not needed in this sum. Because it is just adj A is just a part of the sum actually. So A11, just by applying the formula, the 4 which is written in orange is the minor M11. By ignoring the first row and first column, we get M11 as 4, which has been written directly in the formula as you can see. Then A12, by ignoring the first row and second column, we get M12 as 3, and that has been used in the formula for A12. Thus we find A12 which is minus 3. Similarly, by ignoring the second row first column, we get A21, and by ignoring the second row second column, we get A22. Once that is done, we find adj A. Now here, adjoint of A has also been found directly without finding the cofactor matrix. Remember, the cofactor matrix is just a transpose of the adjoint. So by writing the elements of the cofactor, the rows of the cofactor matrix as the columns of adjoint, we can get directly the adjoint. See here, A11 and A12 have been written as columns over here. Similarly, A21 and A22 also have been written as columns. These would have been the rows in the cofactor matrix. So adj A has been found out directly. Just concentrate on how it is done. Next step, to find A into adj J. I hope you remember how to multiply a matrix by multiplying the corresponding rows and columns. Row 1 with column 1 will give us the element A11. Row 1 with column 2 will give us the element A12. Row 2 multiplied with column 1 will give us A21, and row 2 with column 2 will give us A22. So you can see over here how it has been done. Similarly, adj A into A. Remember, matrix multiplication is not commutative. So as a result, A into adj J need not be equal to adj J into A, but here it is coming as equal. Both of them are giving us the same value as you can see over here. The next step, find mod A into I. Now what is mod A? The determinant of A. So the determinant of A is taken and that is multiplied with I, that is a unit matrix. In this case, unit matrix of order 2. Thus you find the answer for mod A into I, which is coming as a matrix which is equal to the previous two matrices which we found out just now. Thus from the statements 1, 2 and 3, we can say that A into adj J is equal to adj J into A, which is equal to mod A into I. The next sum, a 3 by 3 matrix, you can verify the same concept as an assignment. So this is one of the properties of a matrix. If a square matrix is invertible, then this particular statement is true of the matrix. That is, A into adj J will be same as adj J into A, which will be the same as mod A into I. It is a property of a square matrix which is invertible. By now, you are thorough with finding the cofactors and adjoints of the given matrices. I hope you have practiced enough of the assignments which I had given you. Now the next question is, find the inverse of the given matrix by the adjoint method. So one step further we are going to go over here. As usual, we start with a 2 by 2 matrix. A is the given matrix. Now here, compulsorily, just like you did in transformation, compulsorily find out whether A inverse exists. How to find out whether A inverse exists? By finding mod A. As long as mod A does not come as 0, we can conclude that A inverse exists. And in this case, mod A is coming as 13. Thus our conclusion, and we proceed further by finding the minors of the matrix. Then we find the cofactors of the given matrix by using the formula obviously. Then the cofactor matrix is written by writing A11, A12, etc. in the proper position. Then the adjoint of the given matrix by finding the transpose of the cofactor matrix. And then by using the formula A inverse is equal to 1 upon mod A at J, we find the inverse of the given matrix. So this completes the finding of inverse by adjoint method for a 2 by 2 matrix that is there. These two sums can be done as assignment by you. We go on to a 3 by 3 matrix now. Write the matrix as A, find mod A. Mod A comes out as -3, so we conclude that A inverse exists. Now students, what are we going to do here is that we are not going to find M11 separately. We are going to find it as we do A11. Like this. See, by ignoring the first row and first column, we are going to get M11. So we write M11 in the formula for A11 as a determinant over here. As you can see over here, M11 has been written as a determinant. Then by solving M11, we get the answer for A11. So this does not make you lose your marks. It carries equal number of marks as if you find M11 separately. It saves your time as well during the exam time. So practice by doing this. Then A12 is found out like so by finding M12. Then A13 by ignoring the first row third column using M13 which is there as a result. And then A21, A22, you can see the movements as they are happening here. And A23. Then see, suppose A is the given matrix, the previous matrix I have written here just for your reference. Now what do? We ignore the third row first column to find A31. Then A32 and then A33. And then the cofactor matrix. Then the adjoint by finding the transpose of the cofactor matrix. And then the inverse of A by using 1 upon mod A at J. Mod A is -3, so 1 upon -3 into adjoint matrix gives us the A inverse that is there. Do these three sums as assignment as usual in your notebook. Students, I know it is quite tedious to follow all the steps, keeping in mind all the steps for finding the adjoint of a matrix. But you have to keep practicing, and this method, as I told you earlier, it is easier than transformation. So become thorough, become masters at finding adjoint of a matrix. Because in the next lecture, we are going to use both the methods for finding the solutions of linear equations. Keep practicing. Bye students.